Welcome to the virtual soldering workshop. I am Akbar and let's start. So today's agenda is discussing about different type of soldering irons, the type of soldering iron tips, the solder compositions, what flux is, what the purpose of flux is, the different hazards associated to soldering, preparing a soldering iron tip for soldering, how to maintain the soldering iron, how to solder itself theoretically speaking, and the common mistakes you will face while soldering for the first time, and how to get better at soldering itself. So, there are few categories of soldering irons. There are primarily regulated irons and unregulated irons. The two type of unregulated irons typically found on the market are the butane ones and the resistive ones. The butane ones, as the name suggests, use some sort of fuel to start a flame. That flame heats up the tip of the iron. The regulation they have will be typically some sort of power adjustment. Basically, you can adjust how much the butane gas is consumed, and that can be used to adjust the temperature, roughly speaking. It is more power control than temperature control. But they are far from regulated. They are not really a good way of soldering, even these days if you have to solder remotely away from your workbench. There are much better solutions available on the market, such as portable soldering irons that are powered by USB-C. So you can use a power bank to power them. So I do not recommend anyone purchase a butane based soldering iron. The other type of soldering iron is the resistive one. This is the most common type of soldering iron you will find in the shops. This will have a coil of wire. That coil of wire is a resistive element which simply dissipates power onto the tip, and that is it. It does not have any form of control on it. So again, I do not really recommend these kind of irons even if you have heavy duty work. These kind of soldering irons are available at very high power levels at a low cost. So the low cost is enticing, but at the same time you are investing in a skill, and if you purchase a soldering iron which is unregulated, especially the coil type heating ones, you're basically handicapping yourself. That handicap will greatly affect your soldering ability, and all of the work that you produce with the soldering iron will not be of high quality. So if you have an extreme budget constraint, it is fine to get a coil based heater in your soldering iron. But it is much better to save up and go for something which is somewhat regulated. The price difference these days is not that large. The regulated or at least power controlled soldering irons will be 2 to 3 times the cost of an unregulated iron, but it is really worth it. It is not worth fiddling with a fixed power soldering iron. At least if you have power control, you can somewhat adjust the temperature based on your thermal load. If you have a large thermal load, you can increase the power. If you have a low thermal load, you can decrease the power. Then there are different type of regulated soldering irons. There is the traditional tip construction and there is the all-in-one element construction. The traditional construction will have the heater coil and then it will have a sleeve over it. That sleeve is basically your soldering iron tip. They are indirectly heating the soldering iron tip and they are fine for most people. Most people do not require the all-in-one integrated element tip construction, but it is definitely a nice to have. The cost of replacing the tips on an integrated solution is much higher compared to the traditional one, where you just have the tip sleeve that has to be replaced. The replacement tips on a traditional construction might be less than $1, but the all-in-one systems where the tip and heating element is one unit, those can be multiple dollars. So the cost difference is quite significant and it does matter in a laboratory or an academic environment. So for an academic environment, I would still suggest going for a traditional tip element design, which has the tip sleeve separate from the heating element. So you can replace the heating element separately, which are also quite low cost, and you can replace the tips separately. The heating elements don't fail that often, but the tips can be damaged by amateur solderers. So, and there is also inductive type heating. Basically, the coil of wire inside of the heating element will change in its inductance as you're soldering with it. So there will be a control loop behind it which will feed power to it instantaneously. So that is the most advanced type of soldering iron tip construction, but it is completely unnecessary for most people. It is also quite expensive to manufacture and design. So only the really high-end soldering irons will be inductively heated. Then moving on to the type of tips. There are different type of tips available on the market. The most common type of soldering iron tip is the conical tip, and by far the least useful. For some reason it is by far, by a massive margin, the most common soldering iron tip which is present on the consumer soldering irons, especially the sharp ones. The narrow tips are not that useful simply because they have a poor thermal contact between the soldering iron tip and the joint. You want to have a good amount of thermal contact if you want to have a good thermal transfer, and then you have to have a good joint. So something like a chisel tip, even a knife tip. This over here is a knife tip. This knife tip is quite common as well. So this knife tip is much better than this conical tip when it comes to soldering. You can use this knife tip to apply a good amount of heat using the large surface area present. On the left side you can see some chisel tips. These chisel tips are considered ideal, but I still say these are typically not found in the cheaper kits. So if a chisel tip is not part of the cheaper kit, the knife tip most likely is part of the cheaper kit. So at least go for the knife tip if the chisel tip is not available or not available at a good or low price. But try to avoid the conical tips as much as possible. The only scenario where a conical tip might be useful is if you are working with really small SMD components. Even then, the conical tip is not the best, but it can allow you to do really precise soldering. So conical tips have an excuse when it comes to existing, but they are far from the best. So when you are choosing a tip of a tip style, try to go for the knife tip or go for the chisel tip. There are also the bent conical tips. Again, I don't really recommend them, but the bent conical tip is definitely better than the straight conical tip. The bent conical tip allows you to more ergonomically apply pressure onto the joint, and you have more thermal contact compared to the straight conical tip. You have to hold the soldering iron at quite awkward angles to apply a good amount of surface contact. So considering surface contact, the best is the chisel, then I would say is the knife, and by far the worst by a large margin is the straight conical tip. So if you have the option, do not go for the conical tips like this. This is the default tip that comes with almost all soldering irons. That is just the industry standard for some reason, but you can always get replacement tips. That's why I said in a university or academic environment, you should go for the traditional tip constructions where you have the sleeve as the tip, so you can easily replace them, and they are also quite low cost, and they're also sold by many manufacturers, so it is quite easy to get low cost replacements. Then there are different soldering compositions. The solder itself means the wire which is used to fill the gaps. This is an alloy. It could be a lead alloy or it could be a lead-free alloy. It is recommended to go for a leaded alloy because it is having a lower melting temperature. Having a lower melting temperature makes it much easier to work with. But on the other hand, there are the really heavy soldering wires that you find typically in the shops. You have to completely avoid them because they will be used for welding pipes, welding copper pipes or brass fittings. So those kind of solder wires will be characteristically having a very large diameter, more than 1 millimeter. If you find solder wire which has a diameter of more than 1 millimeter, you should completely avoid it. First of all, it is difficult to control. Secondly, it is most likely acid flux core. That basically means that the flux inside of the wire is acid based. Acid based flux is not used for electronic soldering. It is only used for really heavy soldering to remove really heavy corrosion or really heavy oxidation. As I said, Welding solder is used for welding pipes and brass fittings. It is not used for electronics work. Having an acid flux does not make it better. It simply makes it more corrosive, and that can damage PCBs. PCBs typically are quite clean when you're working with them. If they are not clean and they have a layer of oxidation on them, you're supposed to scrub it clean using a scouring pad rather than using strong fluxes. So I highly suggest use a scouring pad to clean the oxidation of the copper layer. Typically the PCBs will be plated, but the PCBs that you DIY manufacture, they will not be plated. So if you touch the copper part of the PCB, you will oxidize it. So you might have to scrub down with a scouring pad to slightly sand the surface and expose fresh copper. When you expose the fresh copper, even if it is slightly oxidized, the flux in most of the solders, it is able to cut through it. So you don't have to go for strong fluxes. Strong fluxes are also not good for the person which is performing the soldering, as the fumes from the solder flux can be quite irritating, especially the acid core flux. Then, as I said, there is electronic solder. Electronic solder typically has a small diameter and it will not really be marked as electronic solder, but it will be more expensive, that is for sure. The quality of your solder joints depends on the quality of your solder. So cheaping out on solder is not at all advised. Even if you cheap out on your soldering iron, do not cheap out on solder. It makes night and day of a difference. The quality of the alloy makes a really big difference. So even if you cheap out on your soldering iron, do not cheap out on the solder. It makes a big difference, bigger difference than you actually think. It will be the difference between having a clean joint and having something that looks like a rock formation. One of the most common compositions is 60-40. 60-40 means it is 60% lead, 40% tin. This is quite an easy solder to work with. It is typically having a melting point of about 183 degrees Celsius. There will be some variations of this compound. Some will have silver in them, some will have more tin in them, but typically 60-40 is the most common one. And it also has a lower melting point, so it is easy to work with. Trust me, the small difference between the lead-free and leaded solder does make a considerable difference when it comes to ease of soldering. The lead-free solders might have a melting point of like 210 to 230 degrees Celsius. So you're looking at a difference of about 20 to 50 degrees Celsius. And that is quite significant when you're talking about thermal transfer. You need much more heat transferred onto the board before the solder will melt. And it makes lead-free solder quite difficult to work with, especially if you're using weak flux. You might have to use additional flux just to be able to work with lead-free solder. So in the end, you're not really saving the environment by that much if you have to use more flux. But in many countries, leaded solder is completely banned. So you might not have the option of working with it at all. So in that case, your only option is using lead-free solder. But just keep in mind, you will have to work at higher temperatures and you will also have to use additional flux applied to the joint. Because without the additional flux, the flux that is within the soldering iron, within the solder core, might not be sufficient, especially at higher temperatures. The higher the temperature, the quicker the flux will burn off. And then there is solder paste. Solder paste is basically a colloid of flux and balls of solder. It has many tiny balls of solder in it, suspended in a paste flux. So this is not something that you will be working with almost all of the time. You can do even SMD soldering with regular solder, but if you have to do hot air soldering, or if you have to do even with hot air soldering, if you have a soldering iron, you can tin the pads, place the component on top, add some flux, and then heat up the component. That will allow you to reflow the component onto the board. So solder paste is something that you will not typically be exposed to. But if you have solder paste, you have to keep in mind that it has to be refrigerated, as well as it has an expiry date. The expiry date is not that something goes bad in the solder flux or in the solder balls. It is simply it dries up over time. So the longer you keep it, the more dry it will become and the more difficult it will become to work with. If you want to replenish solder paste after its expiry or after it has dried up, simply you have to add more paste flux and mix it up. The consistency might not be the same, but that's basically the solution. Over time, the paste flux dries up, so it becomes a really stiff material. and it is very difficult to work with. Typically, you will have this material inserted into a syringe and dispensed using the syringe. The syringe becomes unmovable if the flux has dried up. So you can remove the solder paste from the syringe and then mix more flux, but it's not a recommended procedure. It's best to just buy more solder flux paste. Then we have been talking about flux for quite a bit. But what exactly is flux? So flux is something which is used to remove oxidation. So whenever you're working with copper or tin joints, there will be a layer of oxidation that builds up. This layer of oxidation basically prevents the intermetallic bond from forming between the PCB, between the lead of the component, and between the filler alloy. This layer of oxidation, if it is not removed, the solder filler material will simply float on the joint and you will not get a good connection. It will be held in by friction, but that is basically it. It can easily break off and it will not make a reliable connection. So flux is basically a material which is used to eat through the oxidation and provide an environment where oxygen is not able to interfere with the intermetallic bond from forming. So flux is typically made of two things: natural rosin and some sort of wax in which it is dispersed in. So it could be natural rosin from tree sap, or it could be some sort of halide or some uh, synthetic flux or synthetic rosin. These days, most of the solder that you have on the market, it is made up of synthetic materials because it is cheaper to manufacture and it is just as effective. You will find on the market these three types. On the leftmost side, you have pure rosin. You are not supposed to work with pure rosin, but a lot of the times pure rosin is sold with soldering iron kits. Basically, this is the material which has to be dispersed in some sort of a wax for it to be useful. Do not use rosin directly, even though rosin directly is effective because it is the active compound when it comes to flux. It is not easy to work with. You have to break it up into dust and then you have to apply the dust. It's not really a fun process. So making your own flux would require you to take this rosin, crush it up into dust, and then you have to mix it with at least 98% alcohol. Do not mix it with anything lower than 98% because a high water content will cause sputtering of the flux. You don't want your soldering joint to sputter because sputtering basically means it spews out metal particles around, and those metal particles can burn you. Even though they are really small, they are really hot. We are looking at temperatures above 300 degrees Celsius. So you can cause micro burns on your skin and it can even fly into your eyes because a lot of people have a habit of soldering extremely close to their face just so they can get a better look at it. So if you have pure rosin on hand, maybe you got it from a kit, you have to crush it, convert it into a dust, and then mix it into a high concentration alcohol. Do not mix it with 80% or 50% alcohol, as that will not work as flux. You'll simply sputter the flux everywhere and it will not be a good experience. Trust me, the process is not worth the cost savings. Flux or rosin is not that cheap compared to flux. A cheap wax flux is not that, the price difference is basically negligible between the two, I would say. A cheap uh, a cheap flux paste is going to be similar cost of making your own rosin based alcohol liquid flux. So avoid it as much as you can, but if you have it on hand, it can work in a pinch. Then coming to the paste flux, as I said, flux is some sort of rosin or some sort of halide which is dispersed into some sort of a wax material. This waxy material makes it easy to apply and there are different concentrations available. Typically, if it is made from natural rosin, the darkness of the color determines how much rosin is present in the flux and how active the flux is. If it is of a darker color, it is typically a stronger flux. If it is a lighter color, typically it is a weaker flux. But that is not a universal truth because, as I said, there are also synthetic rosins or synthetic halides which are used to make flux paste. So it could be completely transparent and it would still be perfectly effective. So if you want, you can cheap out on flux. It doesn't really make that much of a difference. The difference between cheap flux and expensive flux is their activity, how active they are. The cheaper fluxes will not be as effective as the more expensive fluxes, and also the cheaper fluxes will be more difficult to clean compared to the more expensive fluxes. So if you have a commercial application or you are working with something that has to be given into consumers' hands, then I would recommend going for something more expensive, something nicer quality. But if you're working with DIY hobby projects, then it's fine to go for cheaper flux. This is an area where you could save money, but if you buy cheaper flux, you have to use more of it, and the savings are not that significant. So, as I said, it's fine to save money here. The high quality flux and low quality flux, both of them get the job done. Just avoid rosin in its pure form. That is not really an effective way of applying flux, and it's difficult or headache to work with. Then the third type of flux you might find on the market is the liquid flux. Liquid flux is something I don't personally recommend anyone use because it is difficult to apply, I would say. You can apply it with a brush or you can apply it with a pen. Flux pens are fine for SMD soldering, but for through-hole soldering I don't prefer them. I prefer paste flux because paste flux stays in its place. I know when it heats up it will melt and go everywhere, but still I would say paste flux is better than liquid flux. But it depends on the cost. Liquid flux is also quite expensive, so I don't think it is worth the extra cost unless you're purely doing SMD soldering. If you're only doing SMD soldering, then the liquid flux can be easy to apply and it does not really pull up in the place. So if you want to apply flux using a pen with a felt tip or you can use a brush, then liquid flux is fine. But it is more niche compared to the universal use of paste flux. But you can debate it yourself. If you want to do purely small scale SMD soldering, liquid flux can do a better job at application when it comes to ease of application. Otherwise, the paste flux universally can work in all of the different scenarios. Then coming to the different hazards of soldering. The primary hazard is the metal composition and the high temperature. As I said, the solder will have typically two categories: leaded solder, unleaded solder. The leaded solder simply has lead in it, and if you know your heavy metals, lead is a toxic heavy metal. It basically acts on your brain after it accumulates in your body, and it is anything but good for you. You do not directly get acute lead poisoning, but over time lead can build up in your body and it can start to accumulate in your organs, and it is primarily affecting the brain. So high amount of lead content in a person's body is a recipe for disaster, let's say, and you do not immediately notice the effects. That's the issue with it. You will only have long-term effects. You will not get short-term effects. So in the short term you might not notice anything wrong, but in the long term you might start to have symptoms, and the symptoms will go unnoticed because the change happens so slowly. So if you are working with leaded solder, it is highly recommended to thoroughly wash your hands, aggressively wash your hands after you're done working with the solder, and also to keep everything separate in a way that you do not cause cross contamination. Leaded solder is quite soft and it does come off quite easily. It can rub off onto other things. So for example, if you're using your phone while you're soldering, it is not something I recommend because the phone or the phone case can have residual solder accumulate on it, and then it can go around and cross contaminate many things. So as much as you can, try to isolate yourself while you're working on anything when you have leaded solder being handled. So as long as you keep things isolated, you do not cross contaminate, and you wash your hands thoroughly afterwards, you will be perfectly fine when it comes to leaded solder. But no guarantees, you can do your own research. But as far as I'm concerned, I don't think there is that much research available on the internet which is easy to read, but there is a reason it is banned in a lot of countries. It is a heavy metal and it does contaminate the environment when the circuits are discarded. So in commercial applications it is not used. Next is the flux fumes. As you know, the rosins or the synthetic rosin, it will produce smoke when you are working with it. This smoke is not leaded. It does not take lead and throw it up in the air. But what it does do is cause eye irritation and nose irritation. So if you're working for an extended amount of time, do not simply keep your face above the soldering operation and use some sort of a fan. You can use a fan to blow away the smoke. That is more than enough when it comes to keeping the smoke out of your face and preventing irritation. Additionally, I would say keep the room somewhat ventilated. I will not say that you need to keep the room well ventilated, because most people at a hobby level will not be soldering for an excessive amount of time. Unless in your some sort of commercial environment, then you might have multiple people soldering. Then you will have to have the area well ventilated. And air conditioning is not well ventilation. Air conditioner just cycles air in the same place. You have to keep the windows open and you need to have exhaust fans. That is what is meant by well ventilated. So the flux fumes are mostly caused by the rosin burning, and if the fumes stop coming, that means the flux has completely burned off and need to apply more flux. As long as flux is present, the oxidation will not build up, and as long as the oxidation does not build up, the intermetallic bond will form quite easily. Then the most obvious one is burns. You can get upwards of third degree burns when working with soldering irons, as soldering irons can go up to 500 degrees Celsius when it comes to the unregulated high power soldering irons. So if you have an unregulated soldering iron that is anywhere from 60 to 100 watts, it will eventually reach 400 plus degrees Celsius and it will start to glow as well. I have had that experience firsthand where the soldering iron starts to glow a reddish brown color when it becomes really hot. So if that soldering iron tip fell onto your hands or onto your arm, you can easily get third degree burns. Most likely you will get first degree burns, as your body will be able to react to it and move away. But if it is not able to move away, then the damage can be significant. So third degree burns basically means that you need immediate hospitalization and you need treatment. It is the signs of a third degree burn are scar tissue forming, blackening of the tissue, and you have a deep burn. Second degree burns are below your skin level, and first degree burns are just at the surface level of your skin. So first degree burns, you can just wash it in water for 5 to 10 minutes in cold water to ease the burning and stop the heat from dissipating into your muscles. Second degree burns will require some sort of ointment, and it will require some sort of bandaging with dressing. Then moving on to the final hazard, which is solder splatter. As I said in the beginning, if you're working with rosin, you have to use high concentration alcohol to dilute it. Otherwise, the water that is captured in the flux will cause the solder to splatter. This is also true of old solder wire. When you have old solder wire, the flux in the core can absorb water. It is hygroscopic. It is absorbing the water from the air, or hygroscopic. Anyway, the point is that it will absorb water from the air and it can accumulate water to a certain level. So when you start soldering and melting the solder, the water evaporating in the solder core will cause this melted or molten solder to splatter everywhere. It will not be a large splatter, it will be a small splatter, but as I said, some people solder extremely close to their face, and that solder splatter can go into their eyes, and that can cause significant irritation. It can also cause damage to your eyes. So whenever you're soldering, you have to wear safety goggles. It will help with the smoke as well as it will help with the splatter. So safety goggles are extremely important when you're working with any sort of soldering application. So then let's look at how to prepare a soldering iron tip. So whether it is a new iron or it is an iron which has been used for many years, the process is roughly the same. One thing to keep in mind is to never use something harsh such as sandpaper. Never ever use sandpaper on soldering iron tip because the plating on the iron strip is extremely thin. You can easily strip through the plating and then the iron layer. After you go through the iron and tin layer, there is no going back. You have to retin the tip with chemicals. Otherwise, no amount of restoration will work. So if the iron layer is completely gone, the tin layer is completely gone, the tin is on top and then it is the iron layer. Then there is no recovery from that point. You have to start from a fresh tip. So on the top is an example of a soldering iron tip which is worn out but it is still recoverable. And on the bottom is the example of a soldering iron tip which has been tinned properly. So the procedure of cleaning a soldering iron tip is to first of all heat up the iron to operating temperature. The operating temperature for a soldering iron is anywhere from 330 degrees to 370 degrees. Yes, the higher temperature might sound like a lot, but depending on how much thermal mass you're working with, you might want to use upwards of 370 or 380 degrees Celsius. But most of the time, around 330 degrees Celsius is perfectly acceptable. So if your iron is temperature controlled, heat it up to 330 degrees Celsius. If it is not temperature controlled, heat it up to half power. After you heat it up to half power or up to 330 degrees Celsius, you have to clean the tip of the iron using brass wool, which is available on the market or electronic supply stores. This is not the same as the scouring pad that you use for cleaning your dishes. The material is not the same. The material for the dishes is some sort of a tin alloy, but this is a brass alloy, so it is softer on the soldering iron tip. But if you don't have brass wool available to you, it is fine to go with I don't recommend it, but it is fine to go with the steel wool, not the fine steel wool. I'm talking about the coarse one which looks like the one in the image. There is fine steel wool which you can get from the hardware store, and then there is the coarse steel wool which is not really steel, but you can get it from the supermarket supply or household supply stores. If you don't have brass wool available at hand, that gets the job done. I recommend it over a sponge. Sponge is not something I recommend because it thermally shocks the soldering iron. So it is something that a lot of people debate on, but I personally don't suggest it, and it also is not the best way to clean the soldering iron in my experience. It is not as effective as removing the gunk that builds up on the soldering iron tip. So in my experience, going with the brass wool is much more effective compared to going with a wet sponge. The brass wool also slightly abrasives on the soldering iron tip, but that's what I said in the beginning. Do not use harsh substances on the soldering iron tip, and the light amount of rubbing that the brass wool will not cause the soldering iron to lose its plating. So it is fine. You don't have to worry about the plating coming off by using brass wool, as long as you're not using something much more aggressive like the fine steel wool or using something like sandpaper. After you clean the tip of the iron in the brass wool for a few seconds, we have to apply fresh solder to the tip of the iron and let it pull up, and then repeat the process with the brass wool and do this process again and again until you reach a shiny tip. So the example on the bottom is the good soldering iron tip which is completely shiny. Not all the way to the top, but it might be a small portion of the soldering iron tip. In this case, chemical tinning has been used, that's why the entire soldering iron tip is shiny. But in most cases, a small portion on the bottom end will be shiny, rest will be matte. That is perfectly fine. You just have to get the end of the tip to be clean and shiny. Then the process of soldering. So there are certain steps you have to follow exactly. First of all, you have to take the soldering iron tip and then make contact between the PCB and between the leg of the component. You have to keep the soldering iron tip at the joint for a couple of seconds, anywhere from 2 to 5 seconds, depending on the thermal mass you're working with and depending on the temperature of your soldering iron. This is something you will only get with experience. The more soldering you do, the better feel you will get for how much heat to apply in what scenario. So again, you take the tip of the iron, place it between the joint being the copper pad of the PCB and the leg of the component. After you apply heat for a few seconds, you have to add the solder wire to the joint. How much solder wire to add, again you will get with experience and you will get a feel for it over time. So you apply the solder wire for a second or two and then you remove the solder wire. In the entire process, you have to keep the soldering iron on the joint for a few more seconds. After a few more seconds have passed, then you can remove the soldering iron tip and inspect the solder joint. The solder joint should be a curved pyramid shape, like a conical shape. So again, the first thing to do is to heat the leg of the component and then heat the pad as well. So your soldering iron should be placed in a way that it is making contact with both the copper pad on the PCB as well as the leg of the component. Then step 2 is to add solder to the joint. As you add solder to the joint, it will start to pull up. You're not supposed to add too much solder. Again, this is something you will only get by feel. After you add the solder, you have to continue heating the solder so the entire joint can heat soak. When the entire joint heat soaks, it will become a perfect curved conical shape. And then you have to let it cool down for about 10 to 15 seconds, depending on the room temperature and depending on how much airflow is present. You don't have to blow on the solder joint, but it will cool itself. Naturally cooling is the best scenario, so you don't have to mess with it much after that. So the perfect solder joint will be a curved conical shape. As I said, if you add too much solder, it will start to become a blob shape. If it becomes a blob shape, you can simply add flux and then touch the tip of the iron to the solder joint, remove it, put the soldering iron tip in brass wool, touch the tip of the iron to the joint, pull on it, then clean the soldering iron tip in brass wool and repeat. You can do this as many times as you want, as long as flux is present, to remove solder from the joint, and that will allow you to recover from adding too much solder. If you don't have enough solder, the simple solution is to heat up the joint and add more solder. If the joint is cold, you have to add flux and then heat up the solder joint. That will cause the cold joint to thermally wick, and then you can remove the iron and it will be nearly perfect. If you apply too much heat, then you might start to damage the component or you might start to damage the PCB. In that case, there is not much you can do to recover. So it is what it is. You have to just learn to not heat it up so much that the PCB starts to get damaged. The substrate material might start to discolor and darken, and the component might not work afterwards. So that is the sign that you applied too much heat. It is quite difficult to apply too much heat if I'm being frank, but it can happen, especially if you don't have a regulated temperature soldering iron. Then short is basically when you have two leads or two components near to each other and you apply too much solder, the solder bridges between them. The easy fix is to use the soldering iron as a knife. You add flux to the joint and then you use the soldering iron as a knife to cut between the two joints, and you repeat this with brass wool to remove solder until the short is gone. And how to get better at soldering. So the biggest way to improve is to get better equipment. Unfortunately, that is the harsh truth. The better equipment you have, the better quality solder you have, the better you will be at soldering. There is no getting around that. Using poor quality equipment and using poor quality solder will only result in poor quality joints. That is the cold hard truth. So using the correct type of tip, if it is a chisel tip, it is best. If it is a knife tip, it is good. If it is anything else, it is not ideal. Using a temperature regulated iron, these are much more expensive. So as I said, your equipment does make a big difference. The quality of solder wire makes a night and day difference. If you cheap out on everything else, do not cheap out on the soldering wire. And then flux is your friend. The more flux you use, the more room for error you have. Flux basically is error correction for your soldering. And you can remove solder with solder wick and a solder sucker if you have to redo some joints, but it's not recommended to do the rework too many times. It is not good for the PCB as the heat will start to damage it. At that point, you can heat damage the PCB. And that is it. Thank you, and we will conclude.